Thanks to be here for this talk about OpenTelemetry tracing. I will try to speak very fast because I only have 35 minutes, so I've already been introduced. I work for a company called Loft Labs. Anybody knows Loft Labs? Yeah, vCluster? Yeah, great. So we are doing virtualization on Kubernetes. So monitoring, we're a bunch of people sitting in front of a dashboard and waiting in front of computer until the dashboard says, something is happening. And that was what we called alerting. No pager duty at the time. Unfortunately, the systems became more and more distributed. So basically, we can't rely on this anymore. We can't just look at the dashboard and think this is what is happening. For that, we came with the idea of observability. I love Wikipedia definitions. In these presentations, I have 2 Wikipedia definitions, and they are not very good. For example, this one mentions logging and tracing, but doesn't mention metrics. Observability is metrics, logging, and tracing. This talk is about tracing. In general, my talks are a bit longer, so I talk a bit about metrics, and I talk a bit about logging, but because I have only 35 minutes, I will just jump to tracing. Second definition, which again is not super great, so I came with my own definition. Basically, for me, tracing is to follow a business request across all the components of your information system that it's supposed to go through. In a distributed system, that's a very, very good idea. And it's not a new concern. We already had Zipkin or Jaeger or OpenTracing to do that before. The problem is all those free tools, they are on their own proprietary ways to do that. And basically, if you were a tech leader or an architect, you were limited by your choice of framework or library or SDK in which they supported the tool you were using. So in this case, when we have this fragmentation of an ecosystem, in general, at some point there is a force that brings everything together. You know about the comics, we have 14 standards, and I will have one standard to unite them all, and now you have 15 standards. Which is generally what happens, but in order not to have that, you need to have like a powerful organization, an organization with a lot of influence. In that case, that was a W3C. And they created a document called the Trace Context Specification. Who knows about this document? Who has read the document? Yeah. No, you didn't read it, really. I encourage you to read it. It's 20 pages. It's quite easy to read. It's not crazy. And basically, they just define how you can, through an HTTP header, carry several information throughout a sequence of HTTP requests. This HTTP header contains 2 information, the trace ID, and a trace is a business request that flows throughout all of your components, and a span. And the span is something that happens in one of your components. So basically, you can have as multiple spans as something that happens in your component. You can have one span. All spans belong to a trace, and the spans, they are bound to another span in a parent-child relationship. The first span, of course, doesn't have any parent. All the other spans, they have one parent, and a parent can have multiple children. So here, does it work today? No, it doesn't work. Okay, whatever. Here we have the X span, which is the parent one, and something happened in Y and Z. And so the span in Y and the span in Z are children of the span in X. That's pretty straightforward. That's 20 pages summarized into slides. Now comes OpenTelemetry. OpenTelemetry is much larger than just for traces because it does logging and metrics as well. It provides you with a set of APIs and SDKs and tools and libraries. But in our case, it implements the W3C trace context specification. For the record, it's a merge of open tracing and open census, which happens very, very rarely successfully when two open source project merge. At the moment, it's an incubating CNCF project. It's licensed under the Apache v2 license. And this week, it was like 5K followers. It's growing very, very fast. What is interesting to us is it defines how to send data that is OpenTelemetry compatible to an OpenTelemetry collector. And now there is an issue here because it provides itself an OpenTelemetry collector that can accept OpenTelemetry data. This OpenTelemetry collector, however, doesn't store anything. It's just for filtering, enriching, aggregating, splitting, whatever you want. It's to actually change the data, but it doesn't store anything. Afterwards, you send it to a storage, which probably is compatible with the OpenTelemetry collector format as well. For example, Jaeger and Zipkin nowadays, they are compatible with OpenTelemetry. They can serve as OpenTelemetry collectors. So if you just open the right port, you can keep your infrastructure, send OpenTelemetry data to Jaeger or Zipkin, and once every one of your app send OpenTelemetry data, then basically you are not bound to a specific implementation, and you can switch from Jaeger to Zipkin or to whatever you want. Who here is a developer? Mostly developers, cool. Who here is an ops? Some people. So who here is a DevOps, whatever that means, because nobody knows? You know, okay. Great. This presentation is aimed at developers, but if you are an ops or DevOps, then you can point to this presentation so that they make your life easier. As a developer, you have two choices, which depends on the stack. The first is auto-instrumentation. Auto-instrumentation is very good because the developers, they don't even need to know that they will be using OpenTelemetry. In fact, they won't be using OpenTelemetry. It's a runtime concern. It only works if you have a runtime. Python as a runtime, the JVM is a runtime. If you are using Go on Rust, you can't use auto-instrumentation. So in that case, you need to do manual instrumentation. To do manual instrumentation, that means you need to add a dependency to your source code, and the developer need actually to write the code saying, I will create a span here and there. Another way is you start with auto-instrumentation and you need more control. In that case, you can start using auto-instrumentation, and then afterwards, when you want to have, to answer some questions, you can add code. That's what I would advise, to start with auto-instrumentation again, if you can, because if you don't bother the developers, it's low-hanging fruit. You can do shadow IT. You tell nobody anything. You just put an OpenTelemetry compatible collector in a corner. You get the data. When there is a bug, you use the data to solve the problem in your distributed system. And then you can go to your manager and ask him for budget. If you ask him for budget before, there is a high chance, they will evaluate business value versus whatever you are telling me that I don't understand. And so this is a good way to start. Now I will try to do a bit of a demo, which is the main meat of this talk. And I'm a developer advocate, and we are generally ridiculed because we only show hello world application. So I didn't want to look like an idiot, so I have my own hello world application, which is a bit more involved. And I also wanted to demo in many different technologies how it worked, right? So here is an e-commerce application, or at least how you could get data from a product. So first, of course, you go through the API gateway, you go through the product. The first component is a Spring Kotlin application. Who here is a JVM developer? Couple of hands. Okay. Catalog fetches the data, its data from the database, which is a Postgres database. But then I need to know more information. For example, I want to have the price. So I will forward the pricing request to a Flask Python application. Because Python is notoriously slow, I have like cached the result under a vol key, which is the like CNCF Redis kind of stuff. I also ask for the inventory. So I will ask multiple warehouses, whether they have stocks or not. I go through an inventory proxy, which knows all the warehouses to ask. The inventory is in Rust with Axum. The first warehouse EU is still a JVM. Well, it's still a Kotlin Spring application, but I have made it so that it uses GraalVM. So it doesn't run on the JVM, it uses like native bytecode. So you can't use the same OpenTelemetry tricks as in the catalog. Warehouses USA is in Go because I don't know why most people won't Go. I hate it, but whatever. Ruby because I could, and then I have a regular Java app with Quarkus. Finally, I have a recommendation engine. This one is very specific because it works only with on Kubernetes. And something that you probably have never seen and will never see again is I want to propagate the OpenTelemetry context throughout an asynchronous queue. Because I got a lot of questions like, it's about the HTTP header, so how does it work when you don't have an HTTP request? Well, now there is a spec, but I did the code before the spec. It's quite easy. You do the exact same stuff. You take the value of the HTTP header, and you put it as metadata in your message queue or in your Kafka queue, and you recreate the context on the other side. On the deployment side, I have a host cluster, and I will be using vCluster to create a virtual cluster to host whatever is business related, so all my apps and SQL. I also have the OpenTelemetry collector, so the OpenTelemetry collector from OpenTelemetry, and on the host cluster, I have the API gateway. I also have a collector. I have Jaeger. I'm using Jaeger because it's super easy to set up. And I've talked a lot, and I don't have that much time, so I need to start to show you the good stuff. I will start here. I will check out the first, and I will deploy everything. So first, I will create the virtual cluster. Then I will create the namespace for the infrastructure on the host cluster. I will connect to the virtual cluster. So connecting to the virtual cluster, it looks like I'm inside a Kubernetes cluster that is fully isolated from the host cluster, which is super cool. But since I will be needing a couple of services from the host cluster, I'm also using this configuration file, which is here. So the service that is on the host called Valkey Primary will be available as cache inside. Now it has spin on, so now I can deploy my apps. I'm waiting a bit. So the Postgres database is ready. I wanted to be super smart and add a service that waits for the Postgres database to be ready, but it's good. So I might be a bit smart. And now I can curl. local hosts 380/products/1. And I can check here local hosts 380. Well, I was in Oslo yesterday. I had no applause, but I thought in Southern Europe, in Italy, it would be a bit more like, wow! Thank you. Who is a Python developer here? Okay, JVM I asked already. So I will just show you the Python stuff, because there are multiple steps that I want to show you. The first thing is Python. No dependency on OpenTelemetry. Now, how does it work? Well, normally it should be a runtime concern, but I'm using containers. So basically, when I'm creating my app, I'm actually adding the OpenTelemetry dependency, and I'm using now this command, OpenTelemetry bootstrap, which will sniff every dependency and then check if there is an OpenTelemetry related dependency. And it adds it to the dependencies. For example, I'm using Flask. Well, that's great, because now my endpoint is traced. Again, the developer didn't do nothing. I'm using Postgres. Cool. Everything is traced as well. I have the connection, and I even have the exact request that I'm sending in SQL. Wow. Cost, 0. Nothing. That's pretty good. The same goes for Java. The exact same. If you run on the JVM, well, Java, Kotlin, whatever, if it runs on the JVM, it's the same trick. Okay, we can do a bit better. Now I will add the Kubernetes instrumentation. I will deploy again. Because now imagine we want to have additional data. For example, we want to know information about the Kubernetes cluster that we are running. So far we have nothing. And I mentioned that I have 2 OpenTelemetry collectors. So one for the business apps, one for the infrastructure. So I would like to have some stuff. I don't know if you saw, but there is also something called recommendation that doesn't appear here. Why? Well, I will just kill recommendation and start it again and hope that the demo works. In the previous implementation, we had an error here, so I knew it would work. When there was an error, it worked, which is very funny. Well, a warning exactly, but now I don't know, so I need to try and let's see. So I will try product number 2. And I go back here. Here, I find the traces. Let's try. I should have recommendation. If I don't have recommendation, it's not great. Let's try again. Otherwise, I will just leave it. When it doesn't want to work, it just doesn't want to work. That's fine. It doesn't want to work today. It worked yesterday, it doesn't work today. That's fine. Anyway, sorry? Too hot, yeah, it's too hot. Yeah, actually yesterday it was 2 degrees outside. It was a bit cold. What I added here is now I have information about my Kubernetes cluster. And not only about the cluster, about the pod, about the deployment, the namespace, whatever. What did I do? The only thing that I did was to actually configure the OpenTelemetry collector with this. So again, it's practically free to get this kind of information, which is pretty nice. But as I mentioned, you probably want to do better, to have more detail, more information, because at the moment, we don't choose what OpenTelemetry traces. So let's do that. Now, what I'm doing is I'm adding OpenTelemetry itself. And I can use annotations. So I've split this price function in two, and now I have an additional annotation because I can import stuff from OpenTelemetry because I have the dependency. And now I need to kill the cache. Kill the cache. Otherwise, pricing will be protected by the cache and it won't work. Oh, too fast. Oh, too fast. Oh, not good. So what happens here? So the catalog, Redis, it's not happy with Redis. Okay, so Redis is dead. Well, sorry, not Redis, Volky. Oops. Yeah, I was too fast. That's fine. Now I can search. This is what happened multiple times. So you can see, even when I have errors, I have some interesting traces. And now my pricing here has this additional tag, which I added myself with an annotation. That's pretty interesting. And again, because it comes from the same cluster, I have all information related to Kubernetes. How long do I have still? 10 minutes. 10 minutes. I was too fast. That's amazing. Okay, let's do the last stuff. I want now to have full control of the traces, well, of the spans that I'm creating. So instead of having an annotation, I merge everything again, and I'm using the API. I didn't send the request, so I sent the request. Yes. No, I didn't send the request yet. I sent the request, but I didn't deploy the new version. Yes. And now I should try product 3. Yes. Pricing, the same thing that I had, but now it comes from the API. So I don't just need to annotate function and change the structure of my code to add annotation, but I can put them inside of my functions. More importantly, I have added an additional analytics component, which is Node.js. On the Spring side, well, I already asked, so sorry, I can tell you what happens. I can describe the code because I think it's interesting. I've added a filter. So whenever I receive a request, it will go through this filter. This filter gets the global OpenTelemetry instance. So now I have the full power of the API. What can I do? Sorry, not here. What can I do in this filter? Well, so far, I used auto-instrumentation, I used annotation, I used the API, but nothing was about HTTP header or anything. It was completely transparent. The implementation was completely transparent to me. Now what I'm doing is I will get those pieces of data, so the span contexts, the trace ID, the span ID, and the trace flags, which is exactly how the HTTP header is created. And I will recreate it manually. And I store it as metadata in my MQ message. Okay. You have two choices. Either you are using MQ-v5, so you can store it as metadata. If you are using v3 or less, well, you just need to put it in the JSON. It's less clean, but it still works. Then I add additional data that here are, are irrelevant, but I just want to show you how it works. And I publish in the client. And here I end the span. So here I will have a span called analytics filter.filter. And inside I will send the data to my Node.js application. Any Node.js developer here? 1, 2, okay. I guess it works for you. Here I do the exact same opposite. I get the MQ message. I reconstruct the context from the user property, and from that I create the active context. And now what I'm just doing is create a span and end the span. From this point on, I've recreated the context. I could continue making HTTP requests or whatever, but it's enough. So on the other side, I should have like path and client IP. So let's check. I have the path and I have the client IP. And more importantly, I have this like analytic stuff, which is part of my business request, even though it's not an HTTP call. Everything is good. Of course, it's not perfect, because imagine for whatever reason the analytics is not ready. Right? The message will still be stored, and when you restart it again, it means this little square or rectangle will be pushed on one side. So depending on the availability of your service, it might not be a good idea. For example, if you store your messages in Kafka for hours, then it just, you won't be able to display everything, or you will need to find a good display UI to check what you want. And then I'm done. Last slides. You can find me on Blue Sky. You can find me on Mastodon. Twitter, well, you know, it's upside down because I'm still there, but I don't tweet anything about tech anymore. If you're interested about the code, everything is on GitHub. I just put a bit.ly link to check how many people do open the link. Not many, but it's interesting to see. And if you're interested about virtual cluster and vCluster, have a look at the website of my company so I can come next year.
Thank you.
1 minute for questions? Yeah?
Yeah, super precise. We have 1 minute for a couple of questions. One question. Any question from the audience? It was everything clear. I'm going to just double
it was too clear. That's the problem.
It was too clear. I mean,
okay. Yeah.
There is one.
It was first. But okay.
Sorry. So who? We can make it in 30 seconds.
Okay, sorry. You come back after. I will stay there.
No, we can make it.
Okay.
A bit later, so you deserve a little bit.
How important is it to have time properly synced in a globally distributed application when it comes to traces?
It's a very good question. So if you can see here, in some places, it tells you, there is a little issue. I think it's in analytics. Yeah. So here it tells you, there might be some like bad stuff happening. This is not profiling, and this is tracing. So in that case, I don't care that much. If you do profiling, then of course you need to have like the same clock everywhere, but it's a distributed system, so you won't have it. It just needs to be ordered correctly.
No, it was just a joke. You mentioned that you don't like Go, but you still did it.
Yes, I prefer Rust.
Why not .NET?
That's a good question. I wanted to do .NET at some point. The thing is, my .NET skills are 0. Please do. You can add warehouses. I will be happy to have that, and that will be a very good. So what didn't work in this presentation is the recommendation stuff. Normally, it should be an additional, so I will try again here. Let's see if it works. When I do a request on a product, it should see something that is recommendation. And here, I don't know why, it worked yesterday, and for whatever reason, it doesn't now. Yes, yes. Thank you. This trick is even worse than the rest, or better, depending on how you see it. Because now, I don't have anything in my sleeves, no dependency in my sleeves, and no dependency in my pocket. And that's really, really funny. It works with Python, JVM, .NET, Go, and Node.js. How do you achieve that? Well, actually, you need to have the OpenTelemetry operator that Ricardo talked about this morning, and you need to have this instrumenter ready. And then from this point on, only this line. So it's not, you don't bother your devs, you don't bother the people who are building the images, you are just doing your own stuff and you get data. Of course, it's not what exactly you might want, but it still gives you a pretty good idea because here you've got the select from the DB. Because I'm using a DB, and here I have another select, and here I have the HTTP stuff. So it's perhaps not exactly what you want, but it costs even less than auto-instrumentation because the instrumentation comes from Kubernetes. But it works only on Kubernetes, unfortunately. I will stay there until the end of the day. If you have questions, please come to me. Thanks a lot.
Thank you.